know the redundancy. First, we know it's hard to avoid it. Very hard to avoid it. First point. Second point, even if we can avoid it, yeah, it's possible if we try very hard, even if we can avoid it, but still sometimes in some special situations, it is still necessary to keep some of the redundancy. So here we call it controlled redundancy. Yeah. So we are aware of those redundancy. So when we update our data, so we need to make sure our data is consistent. Yeah. So only when we can control the redundancy, we can do that. We can make sure our data is consistent. Yeah. All right. Yeah. Here, all right. So let me start. You know, the slides first. Yeah, and I remember we finished all these things. Yeah, so we're here. Yeah, yeah, because one of the biggest reasons we keep the necessary redundancy, we need this point: faster access. If we store our data in a new table, yeah, because that's a extra storage. That's not original data, that's the derived data. So here we are willing to use more storage space to store derived data. Yeah, here. The goal for faster performance. Yeah. So this point, in our next topic, I will expand this one. Yeah. So this idea, although very simple, but the result could be huge. Yeah. The result could be extremely important. Yeah. So we will expand this idea more in our next topic. Yeah. All right. So here, yeah, as a summary, yeah. So in our database design, so in your mind, you should have this kind of design idea. So what's that? Yeah, so if your business, sometimes your business may need some complex data. So what kind of complex data? Because the original data you stored in multiple tables, you cannot use the original data directly for your business. You have to do some complex data processing work. Yeah. So in the next topic, I will talk about that. You know, Google search engine, you need to do some really sophisticated data processing work on your original data. Okay. But when you do that, you spend a lot of time, and the derived data, very important, very critical to your business. Yeah. Yeah. So then you want to store the derived data. All right. Yeah. So here, yeah. So we stored derived data. Yeah. It could be in a single table, you know, for convenience. Single table access, that's the fastest case. Right? Multi-table access usually slower than single table access because you need to do operations. Okay. You need to combine data from two tables through relation defined in your database definition. Then that operation takes some time. Okay. Yeah. So the fast possible way to do query from single table, if it's possible. Yeah. So if large amount of data, then it's better you use single table for the fastest possible data access. But for small amount of data, then you use multiple data access. That's fine. Small amount of data, right? Yeah. So you won't need a lot of time. Yeah. But large amount of data, if you still use multiple table, yeah, so that could be really bad. Yeah, the result could be very, very slow. Yeah. So think about this kind of understanding. Yeah. Because in your database design, the performance, the response time is the most important thing. Yeah. So you need to have understanding, good understanding on this aspect. Okay. All right. Yeah. All right. So this kind of work we need to do, so we call it denormalization. Just the opposite of the normalization. Yeah. So the natural way, so people feel we want to make our data, with less redundancy. So we want to do normalization. Yeah. So that's looks like the positive direction. Yeah. But here, when we consider fast data access for some derived data, but the data could be very hard to generate, very time consuming. Yeah. So in that situation, we may need to do denormalization, the opposite of the normalization. Okay. Yeah. So this concept. Yeah. Yeah. All right. So with this summary, yeah, because this is a very important topic. Yeah, so I spent a lot of time explain these two concepts, normalization and denormalization. Right. All right. Before I move to the next topic, because one student asked me a software installation question. So here I like to say something about that software installation. Yeah, because we may have a few students with a similar question. So here I probably can help those students. Yeah. Here, that student told me there is a problem in installing the XAMPP. Yeah. So this student used a Windows machine. Yeah. So it's not related to Mac or Windows. Yeah. So even on Windows. But this student has a special situation. So I feel some other students could have the similar situation. So that's the one, because this student is also taking the Java class, 4010 Java class this semester. Yeah. So then there is some conflict software. So here I want to talk about that conflict, because I saw this problem in my previous semesters. Yeah, a few students, similar situation. Yeah. So I like to talk about the conflict thing. Yeah. So some students, if you take the 4010, the Java web technology, that class, because you also need to install software. Yeah, here. But in that class, the way you install software, for MySQL, you use MySQL Workbench. Yeah. So as I know, so you use the interface. The tool to manage MySQL databases is the one called the MySQL Workbench. All right. Yeah. And here, if we run XAMPP in the normal way, then the MySQL inside exam, there is some conflict. Okay, yeah. So based on, my experience working with those students, the conflict is, because when you use the MySQL workbench, one MySQL instance is installed, is running already. Okay, so there is one MySQL instance running on your machine, by default as a Windows service. Okay, it's running, because the software installation in the, when you do it, that is installed in Windows service way. So it's running. When you start your computer, that service is running automatically. Okay, so that means the port is occupied. 3306, that port is occupied by that instance by default. All right, so 30. Then if you install XAMPP, the first thing, that port cannot be used, occupied. So you get error message. The port is occupied. But we can change the port, right? Remember, click the config button, we can change the port. If we change to a different port, although you can start, but if you start a second instance. The first MySQL instance still running there, all right? You do not stop it, it's still running, okay? So you start a second instance, all right, So now you see you have two parallel instances, all right, So then the problem, if we want to use our current way, through XAMPP, we start our web browser, then we use PHP MyAdmin to access MySQL. We cannot. Why? We got an error message. My understanding here, I do not have a solution, okay? I cannot tell you the solution. Here, I just tell you the problem I observed and my interpretation of that on that problem. All right. So the problem, your PHP MyAdmin cannot access MySQL because the first instance has the higher priority. Okay, the MySQL workbench, this instance has higher priority. Higher priority. That means you cannot use the second instance. The first instance is, occupy the main resource. All right. But from PHP MyAdmin, you cannot access that first instance. It is blocked. PHP MyAdmin has not communication channel with the first instance. So that's the problem I observed. All right. Here, my suggestion. When this happened, my suggestion, you do not use PHP MyAdmin to manage your MySQL database. You just use MySQL Workbench to manage your MySQL databases. Okay. So the suggestion, use that MySQL, because this comes from your CS4010. In that class, you need to use this workbench anyway, right? You have to use this tool in that class. Why not just use the same tool in our class, right? Because our goal, we only want to manage, view our data, and run SQL operations. You can do the same thing in that tool, right? So use MySQL Workbench on your MySQL databases for our whole class. How about that? Okay. You do not have to use PHP MyAdmin, right? Yeah. I do not require it. I only need you have some GUI-based tool to do all the query operations and view your data. That's all we need for this class. Yeah. So if that student, I guess probably a few students, several students have the similar situation. Yeah. All right. The next thing is, yeah, because on the same machine, you cannot run these two software tools on the same machine. Yeah, conflict. Yeah, you know, my SQL instance conflict. Yeah, problem. Yeah, but if you have, more than one machines, yeah, then you can install XAMPP on a different machine, right? Yeah. In that way, you can experience the PHP MyAdmin way on a different machine. Yeah. That's also good. Yeah. If you have another machine available, yeah, definitely, you just install a clean copy of XAMPP. Yeah, no conflict. What I mean, clean copy. Okay. Yeah, no interruption, no conflict. Yeah, on a different machine. Yeah. So yeah, just here I make some updates. Yeah, whenever you have any questions, software installation, project question, just give me feedback. Okay. So after I, work with you, then I will give updates to the whole class. Yeah. So try to save some time for most of our students. Yeah. All right. So let me finish that. Yeah. Yeah. Because I need to spend a lot of time in the next topic, data denormalization. Yeah. Here. But mainly I want to talk about that case study, Google search engine. So that's a big idea. Google search engine is so important in our daily life. Yeah. But the main idea of the algorithm, not very complicated. We can understand. With the knowledge we have, the main idea, we can understand easily. Yeah, it's a good fit for this class. Yeah. Also, yeah, I saw a question from the discussion board. That student asked about the data from social media, the hashtag, right? I mentioned a little bit last time. Yeah. So when I talk about Google search engine, I'll also connect to the data in social media. Yeah. Because the way to process the social media data is quite different from the way doing in Google search engine. Two different ways. Yeah. All right. Go simplify the computation. Now, why we do data denormalization? We want to make our computation work as simple as possible. Yeah. In other words, so here, if I expand this statement, if sometimes we may have this situation, okay? We may have this situation. We need a data from complex queries or algorithms. Okay, yeah. Sometimes more than queries, some very complicated algorithms, right? AI, for example, okay? Yeah. AI algorithms also possible. Yeah. So that means the resource we spend to generate the data pretty expensive. Yeah, pretty expensive. Yeah. Yeah, so expensive to generate the data. Yeah, all right, this direction, this direction. Yeah, because it's expensive, so we don't want to redo it another time, right? Yeah, we don't want to redo the work. Yeah, so that's probably millions of dollars if you redo it, right? So we don't want to redo it, okay? So what do we want to do? We save the derived data. Data in new tables. In this way, this kind of data, it's not original data. Okay? It's original, it's not original data. That means if by accident we lost that data, we can generate. The problem is we need to spend a lot of money to generate. Okay, time and money, computing resource, right? Because when you run computer algorithm, you need big server machines. The electricity bills also big, right? Yeah, you need to spend a lot of money. Yeah, all right. But because it's not original, we can generate. Yeah. If you can generate, it's better than the situation that you cannot generate. Sometimes some important data you cannot generate, right? You lost some critical data that the data cannot be recovered. Then that's huge loss. That's not a money issue. That's not a money issue. Even if you spend money, you cannot get it back. Now, that's even worse. Yeah. Here, that's the mainly money issue, resource issue. Yeah. All right, but here you can see we are willing, yeah, we are willing to do the denormalization. Yeah, here, yeah. Here, there is a view. Yeah, so our understanding, so our view on this process. So it is a space performance trade-off. Yeah. So we are willing to use more storage space to get a better performance. So that's the cost we're willing to pay. Okay, yeah. That cost is relatively small. Comparing with the gain we have a lot of gain. Google search engine, think about how much gain you have. Yeah, but I will give you the detail of that story. Yeah, yeah, that's a big gain. Yeah, use more space to exchange for better performance. Yeah, yeah, yeah. With more effort for data consistency. Yeah, definitely. Yeah, because when you update a piece of data, so you need to do a lot of update work. Yeah, so more effort. Yeah, but still, yeah, you're willing to do that. Still, yeah, yeah. All right. So this is here it's a useful idea in application. So this is a useful idea in application. So here, so at this point, what we are talking, so that's the abstract. Okay, so this is abstract discussion. Yeah. Next, we want to make this idea connecting to some concrete real-world applications that we can understand its importance. All right, yeah, next. So a useful idea in real-world applications. Okay, yeah, so let me talk about that. Yeah. Before I talk about the case study, let me talk about, because this idea, you may have a good chance to use the same idea. So many people, you may have good chance to use the same idea in your real-world applications. That's called a pre-processing approach. Pre-processing. Okay? Before you do real processing, yeah, in your business, your business rely on some critical data processing, right? Yeah. Here, this pre-processing, that's not your business critical data processing. No, not that yet. But you need to do some preparation to make your business critical data processing as fast as possible. That's the idea, pre-processing. Yeah. Here, to understand that, so the pre-processing mainly, we mean data preparation. Data preparation. We need to do some data preparation work. Yeah, pre-processing. Yeah. All right. The example is the Google search engine. Google search engine. Yeah. So last time I mentioned why when you type keywords, a few keywords, hit enter, you see the search result usually display in this way. Millions of pages in some fractional seconds, right? That's what you typically see. How you can get millions of pages containing your keywords in fractional second. How fast you can do that? Yeah. How fast? Because that result is generated on the derived data, not on the original data. The derived data, one single table. Yeah. So here, the reason, yeah, let me write in this way. Fast search response comes from, all right, a simple data query from one table, just one table. Okay, yeah. Why you can get a response time so fast? One query from one table. That's the reason how fast it is. All right. Yeah. That's the reason how fast it is. Okay. But how? Yeah. Let me expand the story. Yeah. Let me give you the details of the story. Yeah. Here, there is an important pre-processing procedure. It's called indexing web pages ahead of time. Indexing work. The keyword here is this indexing work. Indexing work. Okay? Yeah. Ahead of time. Yeah. So what do you mean ahead of time? Yeah. For users, before you type the keywords, this indexing work has been done on all the web pages in the world. That's the pre-processing, indexing. Okay? Yeah. So then let me explain the indexing work. Yeah. Next. Yeah. Right. Yeah. Yeah. So, right. Yeah.